Okay, here is the homework where I've gone through how to do the problems. The first one is r equals 2 plus 4 sine theta, and you're supposed to find whether it's symmetric to theta equals pi over 2, theta equals our polar axis, or the pole. Now, over here in this little area, I have put what you should memorize, and if you write this every time you do a problem, try to write it, memorize it, and then try to write it correctly. You'll have this learned. So for symmetric to theta equals pi over 2, you do negative r, negative theta, or you do r pi minus theta. For the polar axis, you change the angle to negative, and then or if that doesn't work, you change r to negative, and then pi minus theta. Change theta to pi minus theta. And then for the pole, you change r to negative, keep theta the same, and then use r positive, and then theta plus pi. So it goes r's positive, r's negative on these other ones, on the ors, and r's positive. And then it's theta minus pi minus theta, pi minus theta, pi plus theta. So that's what you have to memorize in order to know the or parts of each symmetry. I think the first part's easy. So first one, we're checking negative r, negative theta. If we stick that in there, we get negative r is 2 plus 4 sine negative theta, which becomes 2 minus 4 sine theta. And then if you substitute that through, it will be a no. So then we try the r and pi minus theta. And using the identity, we get sine pi cosine theta minus cosine pi sine theta. And this becomes a 0 right here. And you get a minus a negative 1 sine theta. So you end up with 2 plus 4 sine theta. So that is a yes. It is symmetric to theta equals pi over 2. So then you check, keep going. You can't just do one, you have to do all three. Check for the polar axis, and here's me substituting in just a negative theta. And so you would get r equals 2 minus 4 sine theta, so that's a no. And then here's the check for polar. You do negative r and pi minus theta. So you have a minus here. It's sine pi cosine theta, cosine pi sine theta. Same as in your notes. So then you have negative r is 2 plus 4, and the sine pi would make this 0, and you have a minus negative 1 sine theta. So you end up with negative r is 2 plus 4 sine theta. So if you multiply through by negative 1, you get r equals negative 2 minus 4 sine theta. So that's a no. So no to the polar axis. And the third one, if we check with just changing negative r, of course that's not going to give us the same thing. Remember, we're trying to you have to get the exact same formula back again when you replace it with these other items. So we're going to the or part of the pole, which is keep r and change it to pi plus theta. So we have sine pi cosine theta plus cosine pi sine theta, which gives us 2 plus 4 of 0 plus negative sine theta, which is 2 minus 4 sine theta, and we were supposed to have 2 plus. So that is a no also. So there's number 1 on your homework. Number 2 on your homework. Again, I wrote down the formulas to remember, okay, checking for each symmetry, and then I did it. So the first one, I have them kind of sectioned off here. Is it symmetric to theta is pi over 2? The first part came out a no when I substituted negative r and negative theta. But when I substituted r and pi minus theta in, I got a yes. So it was symmetric to theta equals pi over 2. That would be a yes. Polar axis, you know, cosine, remember, it probably, if there's nothing weird, it can be because remember the identity, cosine negative theta, I've said this before, is cosine theta. So a lot of times if you're doing the second one and you have a cosine and you're checking for polar axis, it would be, a lot of times it would be true. So sure enough, if I put negative theta in here, I just get positive theta back. So this one is a yes. So it's symmetric to the polar axis. So a lot of times cosine is called the polar axis symmetry, but it's not always. You can't assume that. But a lot of times that falls through it. And a lot of times sine would be the first one. So let's try the pole. Is it symmetric to the pole or like the origin? And so if we try negative r, it doesn't. But if we try r and pi plus theta, you end up with cosine cosine minus sine sine, and sure enough it comes out to be the same, 2 cosine 2 theta. So this was a no, the polar axis, but the pole was a yes. So it has two types of symmetry. It has symmetric to theta is pi over 2 and the pole. All right, I'll stop the video and move on to the other problems on the next ones.